All right, so this is Daily Desmos Randomness number 0, advanced level. All right, created by Dan Anderson. Let's check this out. Difficulty advanced. Here we go. Can you create the following graph using Desmos.com or some other graphing tool? If you're victorious, leave us a note in the comments when you're done. Hint, this is 360 different arcs. All right, let's give this a try. So I am going to just save this image. Did that save? There we go. We'll save this image, Desmos Graph 1, as a reference. We can toss it in here so we can have a nice little visual reference of what we're doing. Desmos 1, Desmos Graph 1. There we go. All right, check you out. So currently, it goes out to about 4 point. Does that go out to? The radius here, 4.6. 4 point, oh, that's 4.5. Okay, so 4.6, 4.7. So it looks like the radius is 4.7. Okay, so while we have that there, let's just do a simple circle equation, and we'll go equals 4.7 squared to give us a little starting reference here. Now we want to shut that image off, and we can kind of remember what that looks like. We're going to bring this down, and it was called randomness, and it said there were 360 separate arcs. So my first thought is to just make a random variable here. So let's go with random, a equals random, and I want 360 random values. That's a lot of values. Now the issue is I want to well, I'm wondering if I do this completely randomly, there's going to be gaps in the radius where there's really no circle at all. But I see that it really seems like we actually have a circle at every spot going around. So if I do this with circles instead, I mean, I could do it with a polar graph as well, spiraling out. But let's try to do this with circles first. So I might not want to use that just yet. Let's also make a list. Now here's the thing. I want a list of values. I want to go from a radius of 0 out to 4.7, and I want to have 360 little bits. So what if I started with 0, and then I said let's go out to 4.7 over 360? Would that do it? Would that bring me all the way up to 4.7? Let's see. I need to go do my dot. So 361 element list. Okay, so we got to get rid of that first element because we want to follow the rules here. We want to have exactly the right number of elements. Okay, so I'm going to need to go, I guess, twice as big. That's at 9.4. 9.4 over the 360. And now we have 360 elements. Okay, so my idea is if I just replace this 4.7, let's get rid of this so we can see what happens. I'm going to replace 4.7 with the letter B, and I should get all the circles. There we go. There we go. Looks promising. So is this... Yeah, that's going to lag on me a little bit now, but it looks like now if I zoom in, I can kind of see some texture here. I should have 360 separate circles. Okay, so we are not going to be able to keep that on for very long. So let's go back here. Let's change this just to 36. No, that's not the right thing. Well, shoot. So let's, what do we do? Let's not have that be B. If we turn this off, will it stop lagging for a second? I can zoom in and out. Okay. So let's see here. I need to I need to make this not have so much lag when it builds. All right. So I guess my main idea is going to be to, once I have that, to kind of restrict where it's going to be. So if I said, let's let the x values be between, now this is where the random stuff is going to have to come in, because you saw how it was all kind of randomly restricted throughout there. There's different pieces of the circle missing on each and every individual circle. Now, if I zoom in on this, I wonder if I can really tell. There's large chunks of an individual circle missing. Like you can see on this, the outermost circle, it's missing from here down to here. So that's a substantial chunk missing, but it's not like it's not symmetrical. With just if it was only the top part missing, you could say that the y values are restricted. But it looks like it's got to be a combination. So we're going to have a combination of x values and y values restricted here. And let's see how this goes. So if I have these random numbers are going to be from 0 to 1 is how the random function works. So I'm just going to have values from 0 to 1. And what I need each time is whatever the value of b is, that's as far out in the x direction as that one can exist, like from negative b to b, right? And this would be like, again, negative b up to b. But then I want to take chunks out of that. So what if I just subtracted a in a couple places, and we can look at what happens when we graph that. Now this is giving me an error nested too deeply, so maybe I don't want quite so many random elements there. Let's see if we can turn that on now. Okay, so it only brought us out a little ways, and it's a little too random. So what if we did something like multiply them? No. I wanted to do b minus a, but I guess I could do, just a partial. So here, what if we did just a partial, like 0.1a, and then we zoom in there to look at it. Oh, it's like the Death Star. Oh, that's awesome. That's awesome. Okay. Not what we want, but it's pretty cool. So we'll probably have to, let's experiment here. If I shift this down, see it's only taking a chunk out right around the axis, and that's not what I want. So I need this to be taking chunks out that are a little more randomly spaced. That's the interesting thing here. If I make this a lot less, yeah, it doesn't really, even doing this in multiple places, plus 0, oh, that's cool, plus, I like that, Pac-Man, 0, 1, A. Okay, so it's a problem though. I mean, I like it. It's just clearly not what we're trying to do. It looks kind of like a record player. Okay. So really not that random, right? Right, I need this to be far more random, the chunks that we take out. So let's get rid of the whole Y situation. And we're going to look at just taking out pieces here. I might have to do this with polar coordinates. This is getting too hairy, just trying to take out some sort of a restriction here. So we're saying we chose this between negative b and positive b because it was the radius. So we always want our x values. But I want to take a chunk out. It could start anywhere, right? Like it could start anywhere, you know? So depending on what b is, like let's say that the radius is 3, right? I want to be able to take out any sliver of that. Yeah, this is tricky. This is tricky. All right, so let's stop that for a second and let's look at what would this be as a polar coordinates. Now, if I want to do a circle, I think the way to do it is like just sine theta plus cosine theta. Let's see if I'm remembering that correctly. Now, that is making me a nice circle, but it's over there. So I want to figure out how to move this guy around, and I don't remember my polar coordinates very well, as I should. I have to make some sliders here. No, I just did sine theta. That made a circle, so that's nice. So I just have to move this around. Is it theta sine theta? Ooh, that's cool, but not what we're looking for. That makes a heart. Nice one. Heart. No, both go down. What if I square this? Ooh, nice. Okay, just a little exploring, don't mind me. I think we'll probably have to put something in here. Okay, yeah, that brought it down. Okay, so we probably want to go just down pi over 2. No, that didn't do what I thought it would do. Okay. Hey, that was fun. This is interesting. How do I... It doesn't... That's the interesting thing about, polar graphing. It doesn't necessarily come out the way you think it should. So that's, at least that's down a little bit. Now, what if I try to subtract pi here? I brought it to the left. We're going to do pi over 2 here. That brings it back up. That's tricky. Can I do? Well, shoot, I might have to look up how to do a simple circle in polar coordinates. But it made me wonder, what if I just did r equals 4.7? Seriously, that was very, very simple. Okay, so what we want then is r equals b. That gives us all our circles. And then that's from 0 to 2 pi. So we should be able to just restrict theta into sort of a messy situation here. So we've got our 36 random numbers. What we need is 360 random numbers. Oh, that's a lot. Okay. That's so many. It won't let us. You need something in there, it says. Okay. Okay. Let's do this. So theta is currently going from 0 to 2 pi. So I want to randomly take snippets of that out. Okay, so let's start with 0 to 2 pi. But then we could we'll start with, let's say, minus a. All right, we'll kind of see what happens. And we'll make this side plus a. And again, we have the Death Star. Nice. That's a very, very cool graph. Okay. But the thing is, we want to much more randomly take pieces out. Now, that's just going to take larger pieces out. It kind of makes the arc start later. I want it to be able to jump over, right? I want it to be able to sometimes continuously have those pieces, but other times not. So I think what I want is more of a, well, first we got to figure out how big of a value of a makes it so this is available all the way around. I guess it would be 2 pi a. Because if we did that, that is super cool. But we're clearly taking away too much at both ends, and we're not starting any in an interesting kind of middle spot. So don't really want to do that. Oh, let's name this. This is randomness number 0. We don't want to lose our graph in case we forget to save. So this is randomness number 0, Mr. H. here to help. All right. All right, all right. We can do this. So we're getting close. I need to figure out this randomness. So if I want the randomness to include the beginning there, I don't want to add quite so much. I want it to have the option of not adding anything at all the way up to adding pi. I think because I only go halfway around, I can get rid of some of this and have it be filled in quite a bit more. But the problem is, of course, I'm taking out far too much still. Let's look at this picture again. Oh, that's looking more and more pretty. The harder I try to make this thing happen. So that is super interesting. Okay, so I want to take out chunks. I want to take out chunks as this goes around. It's almost like I want theta to skip. I want it to skip random bits. That's what I want theta to do. So let's see. What if I did pi times 1 plus a, and I did up to let's see if I only went to 2 pi. Oh. Oh. So check this out. This is interesting. So places that, let me save this. So places that are the dark black color have been gone over more than once by this circle. So I can actually tell by the different colors here. It looks like we've got obviously the gray color. That's only going around once. But then it seems like, are there different levels beyond that gray color? Doesn't it look like there's kind of a charcoal, and then there's kind of a very dark black color? So we're doing 3 loops, it looks like. So I want to go around my circle 3 full times. Okay, so if I go here and change this to 6 pi, then I've gone around 3 full times. Now the problem is mine looks a little bit too filled in, right? So you see this one, well, if we try to, let's just move this over. Let's just bring this guy over to 10 so we can see it. Oops. Let's just bring this over to 10 like that. Okay, and that way we can see a little side-by-side comparison. All right, so we need to take out a lot more because we're going around 3 times. It's okay to take out some extra. So let's go ahead and do that. So what if I went to 7 minus a? I should be taking out quite a bit more. Now that looks pretty good, but I do feel like it looks a little more random in the test one. I want this quadrant here to get some stuff taken out. So what if I up this? Oh, yes. Yes, what if I make that pi? Oh my goodness. Oh, that looks so good. That looks so good. Now, the trick is to get it to fill in more. I just make it go around more times, right? So if I make this go around 24 pi, make it go around a lot of times, I'll have those black spots. It's too much. It's too much. Okay, so let's back this off. All right, let's look at that. Oh, we're looking good. We're looking good, but How many times around should I let this fill in? I mean, because imagine if I went around just a huge amount of times, isn't it going to fill in all of those random places? I guess it's still going to be restricted the same, right? After a certain point, it's going to have the same restrictions on it, so it's not going to fill it in anymore. It's not going to change at all. So I wonder what the lowest value is. If I do 6, is that the same as 7? Or is 7 the same as 70? Looks like it is. Okay, so we should probably do 6. Is 6 the same as 60? It is. Okay, so 6 pi is probably the best we're going to do. Now mine is filled in a little bit less than that one, but I do like it. What if I get rid of that A? That might have been, wow, that A was doing all of it. Okay, wow, okay. What if I put an A here? It fills it in a little bit, which is what I wanted. Okay. So then if I up this number, it's going to take a little bit more out. Ooh, oh yes. We got it. All right, now that is a pretty tricky little equation. So let's go through this. Let's see what we got. R equals B, where B is this list, goes basically from 0 up to 4.7 for the radius. And then we have this quadratic restriction on both sides that we've built for theta. And we're going to keep going around that circle 3 times to shade it in so that it matches the one over here. Oh, that's a beautiful challenge. All right, so let's save that. And we'll submit this challenge. Nice. All right, randomness number 0. All right, thank you, Daily Desmos. We got it.